So I forgot to do recording. There we go. If I bring that back up, all right, you guys ready?
Sure. We could postpone this.
No, we can't postpone it because you know what? I went yesterday and I planned out the rest of our year. And if we have enough time, we have enough time to do everything I want. I'm so excited. We might be done learning before spring break happens. It's going to be so exciting.
What?
Yes, because I'm good at my job. Yeah. So, I planned out the rest of our year. Hopefully, we'll see what happens in case of snow. Yeah.
If we finish learning before spring break, how much time do we have before the end?
Oh, do you guys want to see the schedule?
Yes.
Pull it up.
I want to see everything you worked for last night.
Oh no, I just compared my calendar to last year's. It wasn't that exciting. I just got to make sure we have time to review. So snow days, barring some snow days, we're still in a pretty good spot. I'm feeling pretty good. So Unit 6, we're going to finish probably by the end of the quarter is about when we'll be taking that test, barring any snow. Unit 7 is the rotation stuff that you guys did last year. Remember rotating a little bit? Some of you might not have gotten to it depending on your teacher. Don't worry if you didn't. I taught it from scratch last year because that's what was cut in 2020. So I'm fully prepared to teach that from scratch again. It's a really fun chapter, and we'll be doing a lot of not actual integrating. We'll be using the calculator to do it. Very visual, very cool. You'll feel very smart looking at the problems because they look really cool. Unit 8 is my favorite in the entire world. It is called convergence and divergence tests. Essentially, if I wanted to explain it to an Algebra 1 student, if you add up infinitely many numbers, do you get a number or do you get infinity? Answer, it depends. And we'll figure out how to figure that out. Chapter 9 or Unit 9 is Taylor series. So that's the big boy unit there. And then 10 is like polar, parametric, and vector. It'll kind of return us to integrating because in units 8 and 9, we don't really do too many integrals and derivatives. It's going to be a lot of series stuff. So if we can get everything done, look at this. We are testing right before spring break. We'll be able to make our way pretty much through a full practice AP test before our AP exam on the 9th of May. I will say if we have to crunch this review a little bit, that's totally okay. I can start building in some things while we do, especially Unit 10. Some of those lessons are a little bit easier. Unit 9 will probably be doing a lot of notes, but it'll be fine. So just so you know, the rest of our year looking great. I'm feeling really good about this schedule, even if we have to push some things later. Right now, I'm feeling super comfortable with where we're at. It's not. You guys are doing a great job. Just know that. I'm just really excited that we're not like super behind, you know? We're like a couple of days behind where I was 2 years ago, but like 2 years ago, everything was completely normal. So a couple of days behind is great. Yeah, Mia. It depends on what you find difficult. For most people, it's 9, that Taylor series unit, because it's just a lot of stuff and it's very different from everything you've done before. 10 goes a little fast because it's right at the very end, but about 2/3 of that unit is super easy. So it kind of just depends. Most people like 8, but I think that's because I really like 8, so I'm very enthusiastic. Okay. So let's go ahead and we're going to try some questions on partial fractions today. The first question is going to be a review, but we have 1, 2, 3, 4, maximum 6 questions we're going to be doing today. It'll probably take a while.
I made it out to take out. Whatever.
Yeah, that's the problem with that.
You asked.
Whatever you want. I was really good about that, like, I would do it, like, and then now it's just like, oh yeah, let's do it.
Oh, both the twins are gone today?
Yeah, I literally just need like the moral support. You literally both like went
Yeah, but in the next just, yeah, I'm not really multi-variable. Well, it's JV.
Yes, Austin is on.
Yeah.
All right.
Actually, no, something like
James won.
Yes, James is great.
Crushed it.
Austin is nasty. You did 55 hurdles? Austin did really well.
Woo! I don't even know how you even run that race. It's just like too fast.
Yeah, it's very hard.
I'm a terrible sprinter though. I flail too much.
I honestly play a lot too.
Lily knows. I do flail.
I don't. Can I go based off
All right, let's get started. So if you care, this is partial fractions is the very first thing I ever taught as a student teacher. Like this is the first lesson I ever taught as a baby teacher, like 15 years ago. That's when I was 16. My time's a little off, but I'm pretty old. So we're gonna do one review question. This question is not about partial fractions. Does anyone know what method we might use for this one? Did you say that because you read it, or you said it because you looked at the integral? Okay. So let's look at this integral and let's see why this might be a good one to do with the integration by parts. If I look at this integrand, what did we talk about last time? Looking at that integrand, why we might want to use integration by parts. Yeah, it looks like if I were taking a derivative of that, I would need product rule. Anything where there's a product, generally a good time to use integration by parts. Now, I wanted to pull this one. It's one of my favorite questions. One, because it deals with the method of integrating that I like, integration by parts. Two, it has bounds. And three, it has me interacting with a table. This is more so where the AP test is pushing, having you work with tables and graphs and context rather than just functions. So, what was our first step in integration by parts last class? What is U? What do you guys think? All right, what do we think? All right, who likes X as U? All right, who likes F double prime? All right, let's think about it. So what do we normally do to the U thing, whatever we choose as U? We take the derivative. So if we take the derivative of X, we know that that's just 1. If we take the derivative of F double prime, what would that be? F triple prime. Do we have any information about F triple prime in the table? No. Yeah, so we don't have anything about F triple prime in the table. So I think my gut is telling me, like most of the class, that I'm going to try X. But I'm okay. If I get to the point where I don't know what I'm doing anymore, I'm okay. I realize I can switch my U. All right, so that means my du is just dx. What other thing did we identify last class? dv. All right, how did we figure out what dv was? Everything else. So F double prime of x dx. So you guys told me if I had it as u and took the derivative, it would be F triple prime. So what do you think happens when we integrate to get v? F prime. All right, remind me. How does integration by parts go? Uv. So u is x, v is F prime of x. And then is it plus or minus? Minus the integral, of v F prime of x du dx. Does anyone notice anything that I have kind of just ignored? Yeah, the bounds. and I'm going to ignore them until I am done integrating. If you wanted to notate with the bounds, just a reminder from last class that we would have to put them both here and here. Or you can just wait. So I'll kind of leave, I'll do a black version of this problem and the yellow version. All right. All right, so this guy is just hanging out. Anyone know the integral of f prime? F. And why didn't I need to use integration by parts for this second part? Yeah, there's no product here anymore. It's just one kind of factor going on. And I know the integral of it. I know it's antiderivative. That would be f of x. And if I wanted to notate the bounds, I would put 0 to 1 here now, kind of applying to this whole expression. All right, kind of looking forward. I have successfully integrated this, but I notice all my answers are numbers. Will I have enough information to find my answer? All right, then find my answer. No, we won't do the plus c here because I have these bounds on it. So I won't need a plus c at all. If I were doing this without the bounds here, you could have a plus c, but then you'd want to kind of put the bounds back on. Yeah. Actually, I don't want to do all that. Does anyone have an answer yet? 3. Yeah, I'm gonna plug in 1 now. F prime of 1. What did you guys get for f prime of 1? Cool, cool, cool. Me too. What about f of 1? Yeah. Like that. This one's 0. I don't care what f prime of 0 is. And then f of 0. 1. Y is x.
Oh, you're just solving. You're plugging.
Yeah.
What f prime of 0 is.
Because since I have this x here, it's 0 times f prime of 0. And 0 times anything is 0. I could put it in if I wanted to. I was just being lazy. All right, so I've got first set of parentheses is 4. Second set of parentheses is -1, so minus -1. Are we supportive of 5? Cool. Yeah. Here.
Is that the part where you would add the balance?
Yes. Yeah, so if I were notating this differently, let's say I left off the bounds. If I left off the bounds, so then my integral would be x f prime of x minus f of x. Here, maybe having the plus c. Then I would just kind of have a different step, and I might write down in words like add in the bounds and then plug them in somehow. You just want to make sure that this, oh, let me point over here. You want to make sure that you never set this function equal to this number because they're not equal all of the time. So anything with bounds can be set equal to each other. Anything without bounds can be set equal to each other. You can kind of just use arrows or whatever you'd like to kind of separate. Maybe 2 separate columns. Like that. So very cool question. I've seen them ask about integration by parts a couple of times this way. Just be prepared that depending on the information they give you in the table, they could switch up which way they want you to kind of plug in stuff. All right. So partial fractions. I'm really not going to write down any notes before we start doing questions. So you're going to see me off to the side say, let's just do examples because it really doesn't make sense to talk about it when there's not a question. So let me first start to scroll through some of the questions so we can see what type of integrand are we looking for. So we've already talked about integration by parts was something that looked like a product. These are going to look very different. So here's one example. Another example. Another example. Yeah, so what kinds of things do you think are going to happen in this question? All right, factoring. That's definitely going to happen. What do you notice about all of these questions? They're all fractions. That makes sense, called partial fractions. And the idea of factoring is a really important one. Partial fractions is going to happen when we have a fraction where the denominator is factorable. So we talked about last class, some of those questions where we use like arctangent and completing the square, that was really extra. Those denominators were not factorable. These ones are going to be, and that's a very important part. So you're looking for a fraction where the denominator is factorable. We'll also talk about the fact that these can't be improper fractions. So the degree on the bottom has to be bigger than the degree on the top. So notice I have squared on the bottom and no x's on the top. I can do squared on the bottom and x on the top, cubed on the bottom, squared on the top. We'll talk about what has to happen if this is bigger on the top. You won't like the answer. All right. I know. It's just my job to inspire the youth of tomorrow. All right. So speaking of factoring, can you factor the bottom for me? This one is just x squared chains. So x minus 4. I would recommend learning how to factor before you take the Unit 6 test. Mm-hmm. All right, can you confirm that it's x minus 4, x plus 2? Cool. Although if you ask me for help factoring on the Unit 6 test, you will not be the first nor the last person who has asked me for help factoring on this test. Remember one person? No, it was, yeah. I think it was in Taylor series though. No, it was in Unit 8 because they came up and they were like, I know this is a telescoping series and I know when I'm supposed to do this. If the sum is this minus this, if I do this, but I cannot factor, and they were trying to factor this. And I was like, Justin, it's okay. Telescoping series are really cool. Series are really cool in general. All right, so what we're going to try to do is we're going to try to claim that this is actually two different fractions being added together. And our goal in partial fractions is to use a heck of a lot of algebra. None of it's particularly hard, but a good deal of algebra to find what two fractions this is equal to. The two fractions that I'm going to be adding together have denominators of x minus 4 and x plus 2. So it's almost like I'm uncommon denominatoring. All right. I'm going to claim that this top fraction has a number on the top that I don't know yet. And this fraction has a number on the top that I don't know yet. I'm using capital A, B, and C because that's kind of commonplace in textbooks, but you could use any letter that's not X or that's not like assigned to a number like E. All right, are we ready? All right, so we're going to take a pause from calculus to do quite a bit of algebra. It's not hard algebra. I promise it's not. It's just a little long. Okay, we're going to go through it. By the time we're done with the notes today, you're going to be very good at this because it's the same thing over and over. All right, I'm going to be quite a bit explicit with this first example. So I'm going to write a lot of steps down. You can start thinking about which steps you need, which steps you don't need. But I'm going to try to be very, very explicit this first time around. So I'm claiming, notice that I'm kind of ignoring the integrals for a second. I'm claiming that these two fractions are equal to this one fraction if I combine the denominators. Now, this is all well and good with all of these fractions here, but when I'm solving equations, I don't love to have fractions in there. So I'm going to try to clear the fractions from this entire thing. So I have kind of one big long equation that has no fractions in it whatsoever. An easy way to do that is multiply by the common denominator on both sides. And that's going to be this thing because I uncommon denominator to get these two guys. So I'm going to multiply on both sides by x minus 4, x plus 2. This pink stuff right here is probably not a step you'll see me writing in most of the questions that I do in my brain, but I want you to see where all of the pieces are coming from. All right, now I might do a good deal of pointing at the board. So I'm going to try to distribute this into these two guys right here. And I would argue some stuff conveniently cancels. So if I'm multiplying these two things by the a fraction, what's going to cancel and go away? X minus 4 will cancel. So I'll be left with the capital A and x plus 2. For the second term, what will cancel? X plus 2. And I'll be left with b times x minus 4. A kind of easy way to think about that is it's going to have whatever factor wasn't underneath it when you kind of simplify. On the right-hand side, what will be left over? Just 1. All right. There are a couple of ways to go about solving this equation to find a and b. We're going to use the easiest one because you're going to like it the most. When I think about solving this equation, you may say, Hefty, there are too many variables in that equation. And I would agree. I don't usually have 3 variables in one equation that I would like to solve. So what we're going to do is we're going to use the idea that we want this equation to be true no matter what value of x we choose. So we're going to take advantage of that and choose 2 very specific and very convenient values of x. I'm going to show you one, and then you're immediately going to know what the other one is. I am going to choose the x value, x equals -2. I think that will be convenient and will help me solve for one of the letters. Do you already know what the other one is? What is it? It's 4. So I'm going to choose what one of the factors will make that factor 0, so that when I go and solve, I'm going to be able to solve for a and b. Now, there is another way to find those numbers, but it involves solving a system of equations by either substitution or elimination. So I'm guessing you probably don't want to do that. So we're going to do it this way with convenient x values. I didn't know about this until I started teaching, so you're welcome. Whoa, I know. Hold, please. I haven't stopped girls from filming a TikTok in the bathroom yesterday. I was like, y'all need to go, and they're 2 of my students. I was like, I know who you are. I was like, go back to class. And they're like, okay. And then they just continued. I was like, it is not TikTok time. All right. All right. So when I plug in -2, when I plug in -2, do you agree that a times x minus 2, that's all 0? All right, when I plug in -2 to x in b times x minus 4, I'm going to get b times -6. Notice that once I plug in that x value, I literally have 1 variable left over. It is b. I can solve for it. I get b equals -1/6. While a lot of these times these numbers will be nice, it's not guaranteed. So for the first couple examples, they're not going to be nice numbers, just to show you that they don't have to be like whole numbers. All right, for x equals 4, when I plug in, I'm going to get 6a. B times 0 equals 1. Again, if you get comfortable and you don't have to write the plus zeros, that's fine. I'm just being really explicit as I write down right now. All right, so what's a? All right, now I know you guys have pattern making brains. They are not always just opposite signs of each other. And you'll see that. I just want to nix it already. A lot of the times they're different numbers. All right, now kind of comes the depressing part of partial fractions. We were originally in an integral, so we need to go back to that integral. The nice part is this is going to be really easy to integrate once we get there. So I'm going to kind of go back up to this spot right here, and I'm going to plug in my a and my b. I'm just going to do it down at the bottom. All right, yeah, let's just write it at the top. I'm going to do 1/6. That's a over x minus 4 plus -1/6. Okay, let's fix it then. All right, if you are like James and you hate double fractions, or also like me, I don't like that either. Let's factor a 1/6 out. Wow. I feel like such an old lady when I get mad at things like that. Though. Like that teachers look like, don't do that. Yeah, I pulled the girls that were filming the TikTok, they like wouldn't leave. So I pulled up, I'll wait until you leave. Like, I'm an old lady now. I'll wait. All right. Anyone think they know how to integrate these? 1 over x minus 4, 1 over x plus 2. What function is going to pop up? Say it louder for everyone to hear. Natural log. Now, we have to be careful about u substitution, but I would argue the derivative of the bottom of these is 1. So for these u subs, I can treat the x minus 4 kind of just like 1 over x because there's no constants to take care of. So apologies that I'm going to write over to the side because I know your paper doesn't have a side like mine does. I'm going to have 1/6 and I'll have natural log absolute value of x minus 4 minus natural log absolute value of x plus 2. Yes, there are. I'm not going to lie. All right, so I could technically be done right here. I will say a lot of these questions pop up in the multiple choice. And for some reason, they really love using some log rules to simplify their answers. Does anyone remember what subtraction on the outside of a log, what I can do if I shove that on the inside of a natural log? One thing I can do if I have subtract 2 logs, that's the same thing as comboing them into 1 log and dividing. Okay. That's not something you have to do yourself, but I can almost guarantee you the answer on the multiple choice, if they can do that, they will. It has to do a lot with exponent rules. For right now, just trust me if you want a longer explanation. All right, so we're just gonna practice this a couple of more times. Yeah, sorry that I wasn't very organized this time. We're gonna just practice this a couple more times. You're gonna notice the process is 1, very similar every time, and 2, the integrals at the bottom will be pretty easy every time because we are always gonna be dealing with a number on the top and a linear term on the bottom. So it's always gonna pop into a natural log for us. You'll notice as we go, we are only dealing with a very specific case of partial fractions where the bottom is distinct linear factors. So one thing that will always happen, these will always be different from each other. That's the distinct part. And the linear means we won't have any x squared. You actually have to do a lot more effort if they are not distinct or not linear. If you're interested in that, I used to teach all of the types of this, but it gets a little weird and very big very quickly. All right. Example dos. All right, why am I thinking partial fractions? I can? All right, factor the bottom for me then. All right, let's not spoil it. Everyone try to factor the bottom real quick. Jill, I bet you have it. I'm just gonna, I will come back to you then. I will come back to you. What? Anyone got the factors? Oh wait, Jill, you said you were going to? All right. Do we support Jill's factoring?
I don't know yet. Okay, now yes.
Yes?
I just do Rubik, so it takes me like an extra 30 seconds to do that. Yeah.
All right. Are we ready? Let me, I'll wait. I know, I can actually see that today. You guys are leaving early on Thursday? Wait, it's Wednesday. I don't care. The track people again. I don't like when they steal all of my class at once. No. All right, can we be ready to go now? All right, so again, I have two factors that are both linear on the bottom. They have x to the first power. They are distinct. They are different. So I'm going to do capital A over 2x plus 1, capital B over x minus 5. I should note, it doesn't matter which one you put A and put B on top of, but I will say if you're doing this problem next to a friend, and you're comparing your A and your B, before you start fighting about what they are, confirm that you put A and B over the same thing. I'm going to say that this is equal to x plus 3 all over this guy. Now, I would love if your equal signs actually meant equal signs, so don't be lazy and like leave the denominator off. This does take a long time to write, but none of the steps are super horrific. All right, I'm going to be multiplying on both sides by this common denominator. I don't really like to write down that step though, so hopefully we can get through it without it. If I multiply by that on both sides, what factor will be next to A? X minus 5. What factor will be next to B? Now, what? Not. What's going to be left on the right-hand side? X plus 3. So here's the slightly harder part. What do you think is going to happen on the right? Yeah, I have to plug in the x value. Oh my God. All right. Speaking of x values. All right, one's going to be 5. That's convenient. Yeah, what fraction? -1/2. So not my favorite number, but not horrific. The other way to do this you wouldn't like very much. All right, should we take a second and see if we can all get the same A and B? They should not be nice numbers. They're going to be fractions. You're not going to like them very much, but it's not a big deal. So take a second, see if you can find A and B. Confirm with a neighbor as long as you know that A was on top of 2x plus 1. No, you're good. Yeah. Did I add wrong?
I didn't play with actual scripts.
Oh. Or maybe because this is the second problem you've ever done. You even answered that question.
Integers and fractions are added. Oh. Then I guess I love nobody else. I don't know. Yeah, I don't know how to do this. Wait, why did this do this?
Multiply by 2 on both sides.
What?
Multiply by 2 on both sides. All right. Do you agree with me? Yes? Weirdly. Oh, perfect. All right, so again, not guaranteed that these are going to be nice numbers. A lot of the times they are, but just don't freak out if they're fractions. Weirdly enough, a lot of the time the fractions tend to have the same denominator, even though it like what didn't appear to happen that way. That's a pattern I've noticed, but not confirmed by any means. So just throwing that out there. The most depressing part, though, we are now maybe halfway done. We have to plug those A's and B's back in and then integrate. Yeah, that's the good question, is where do we put the rest of it? I'm going to roll down here. We don't have very much left. We have like copy down the integral and then integrate. That's it. But so maybe 2 lines, wherever you have space for 2 lines. All right, I have 2x plus 1 on the bottom here, and a was -5/11. You could put that out in front if the fraction in fraction is creeping you out, but you would have to split the integral into 2 pieces then, because you have 2 different numbers going on. So I'm just going to be a little lazy and roll with it this way. All right, and then 8/11. Wow. All right, there is one part of this question that is harder than the last question. Can anyone see what it is? Okay, I can't factor out the number. What? The 2x. What do you think that will do? All right, so I would encourage you here not to actually do the u substitution, but to kind of do it in your head. So let's really talk about what's happening there so that in the future, you don't have to do the whole substitution. Because really, this isn't going to change our integral a whole lot. So if I were going to do u sub on this first fraction, what would I set as u? I'm going to roll the +1 in there as well. So do the whole denominator. What would that make du? 2 with the dx. I wouldn't have that 2, so I'd divide it to the other side as 1/2 du equals dx. So I'd urge you to think about the only thing that u sub is going to do is chuck a 1/2 out in front of that integral. Do you kind of agree with that? Yes, ma'am. Yes, exactly. So if it was 3x plus 1, 5x plus 6, whatever number this is, it's going to chuck 1 over that number out in front of our integral. No, we won't. So we're only going to deal with distinct nonlinear factors, because if there's a squared down there, I actually can't just put an a at the top. I have to do a linear. It gets really confusing really fast. All right, so I'm going to keep this number out front, the -5/11, kind of like I did the 1/6. But now when I integrate, I'm not just going to get natural log absolute value of 2x plus 1. What's going to go in front of this guy? 1/2. Let's see if you were listening. If this were instead 4x plus 1, what fraction would this be? Good. Okay. Just making sure. All right. Plus 8/11. Does this one need any sort of fraction, any sort of u sub? No. The reason we just have an x to the -5, that derivative would be nothing, so it doesn't really matter. Natural log x minus 5. Am I done? Plus c. Yeah, please don't leave off your c's. It's the worst thing that I have to take off points for, because you've done all of this crazy work. And there you go. All right, if the numbers out front are as nasty as that, there is no way they're going to try to combine these logs here. So you would probably only see maybe this getting turned into -5/22. I ran out of room, though, so I'm not going to do that. All right, so not too hard, right? It's just long. All right, we want to do, can we do one more before break? Cool. All right, this is a little bit of a how do I make it harder? So how do I make it harder? I just make it longer. So can you factor the bottom for me? Yes. Okay, I factor out the x first. That gives me x squared minus 4, x plus 2, x minus 2. So I've got x plus 2, x minus 2. These types of questions, it really pays to just be very methodical about it, one step at a time. Don't freak out. Yeah, but that means this test is only going to have like maybe 10 questions on it. The AP test is just a flurry of activity, and you just kind of hope your brain doesn't melt. I was like, yeah, it's supposed to feel bad. Like, I almost cried during my BC test, and I got a 5, so here we are. I almost left a full free response blank. Almost a full one. You can leave a full free response blank. Yeah. We're not going to do that this year. No, I know. I do not give two anythings about what happened last year. You guys are so much more prepared this year. It's going to be great. I did not ask Microsoft Word to open. No, thank you. All right, so back to James's question of like, how do I make this harder? What's going to happen here? I'm going to have a over x plus b over x plus 2 plus c over x minus 2. So, yes.
Isn't it bad that we have x squared on top one?
We need to compare the original degree, so squared on the top, cubed on the bottom. Cool. But we do want to check that because the next one we do after break, we're going to have cubed on the top, squared on the bottom. That's a problem. Thank you for checking that, though. All right, so x squared plus 12x plus 12. All right, we're going to multiply this through together, and then we're going to talk, then I'm going to kind of set you free on the algebra of it. So interesting part that's happening here, again, I probably wouldn't write this down in most of the cases, but here is what we're multiplying by, this common denominator still. What do you kind of notice is going to happen on the left-hand side here? That was a vague question. I'm kind of hoping for a specific answer, but I'll answer it myself if I need to. Yeah, there's going to be more stuff left over. So one of the factors will cancel, but we're going to be left with 2 on each term. So for A, the x's will cancel, but we'll be left with x plus 2, x minus 2. B, the x plus 2's will cancel, but we'll be left with x and x minus 2. C, the x minus 2's will cancel, we'll be left with x and x plus 2. On this side, we do have quite a bit to plug into. So here, again, I apologize if you don't like writing. If you don't like writing, this is just not your method. Before I send you just on your way to do some arithmetic. Arithmetic fans. I think that is Mr. Brown. Can anyone give me some convenient x values? 2. Negative 2. I actually don't like 1. 0. Now, theoretically, your third x value could be whatever you want because you'd have 2 of the a's and b's and c's already, and you could plug those back in. So plug these in whatever order you want. I will tell you they're all integers, so whole numbers, negative or positive. So I would like you to try in the next few minutes to find me A, B, and C. Be really methodical about it. It's very easy to mess up the arithmetic, so use as many steps as you need. But notice, it's going to be pretty easy once we find those numbers. So I'm going to give you a few minutes, going to walk around until I see most people have them. They should be nice numbers, whole numbers, either positive or negative. Yeah, so each number you plug in. right, I'm gonna start doing some of the arithmetic. Someone was fully asleep for a second. Like, I know this is kind of boring, but actually, this is like this is some of my favorite stuff. Mhm. I can show you guys. Actually, maybe I'll make it a bonus question. I have a one integral that I always do when I'm bored. Yeah, it involves partial fractions, lots of natural logs, and some arctangent. It's very fun. I'll put it up at the end of class today. It's very fun. What is that? 16 plus 24, 40? It's a good lesson in like figure out how much work you need to write down for yourself.
I like to write it shorter and shorter as I went on. I like to write it all.
See, I get so overwhelmed if I do too many steps in my head. Do you see is 5? Oh, 6. Are they all nice numbers?
Yeah.
You're probably good. Negative 2 is harder.
I think I got it right.
-1?
Yeah, negative 1.
Oh, 0 is the easiest one. Yes.
Are you really sure?
Yeah, I've done this problem. I did it like 30 minutes ago. Yeah, I'm up here like pretending I'm having a hard time. I just did this. It's called acting. -3?
Yes.
How's that? Yeah, kind of. But look at the denominators. I mean, there's going to be like 2 of these on your 10-question test. So.
Where you get it for an hour and a half.
All right, so I'm going to plug back in. I've got -3 over x plus -1 over x plus 2 plus 5 over x minus 2. Honestly, people usually do pretty well with this method on tests. The only thing people usually forget is to check for U-sub. So I'm going to make a real big deal about it right now. Do we need any U-sub on this one? No, not at all. How would we know if we did some U-sub? 2x, 5x, something like that. So I'm just going to roll with this. I got -3 natural log absolute value of x minus natural log absolute value of x plus 2 plus 5 natural log absolute value of x minus 2 plus c. Now, not to freak you out, but there is a fancy way to simplify this. I'm just going to show you. Again, this is not something you have to do, but could be something they do in the multiple choice. Does anyone remember what you can do if you have a number out here? Yeah, you can bring it up as a power on this. And then anything negative, like we said with the subtraction, could go into the denominator. So I'm going to write what I would consider also an answer to this question. I want you just kind of to just ponder it a little bit. So I could bring all of this in as, let's see, who's positive? X minus 2 to the 5th over x cubed x plus 2. Yes. So, and this would probably even be a little excessive for the AP test. So let me talk about where I'm putting these things. 3 length of power, 5 length of power. Since these are both negative, think of like subtraction. That's why they're on the denominator. Since this guy's opposite on the numerator. So just to kind of review some of those log rules, they will sometimes use those to combine. Usually it's only if they're subtraction. They just like making that one fraction in there. Cool. All right, if you could do that problem and you understand when you need to do use substitution, you've got like 90% of any question I would ever ask you about partial fractions. We are going to do 2 more questions. I will say this one is hard, this one is easy. So let's take a solid break because we are pretty good on timing right now. Let's go 5 minutes, not 37. Okay, I would love to. It looks really smart though. This is the time of the year that I start to love because we just look intelligent.
I wrote up all of my things, so it's like really long.
Voice.
This
I
looks so
love it.
satisfying.
I like it.
It's so organized. Makes me so happy.
Yes, I got mine a while ago. It destroyed me.
I got mine on Monday. I was not here yesterday.
Oh no, I rocked an 101-degree fever for like 24 hours.
Wow.
It was the worst.
So I had the flu over. This is great. When I got my booster when I woke up yesterday, I felt like I had the flu again, except everything was like baby flu. It was like
Yeah.
baby flu.
Yeah.
And now my arm was still worse.
Yeah, mine was worse than my second shot wasn't too bad. My first shot I was down for like 2 or 3 days.
Yeah, my first shot killed me. My second shot was like my arm was sore, I'm a little nauseous.
Yeah.
And then my booster was like
Yeah.
shot 101.
Which, like, they keep talking about having more boosters, and I'm like, I understand why, because I don't want to get COVID, but like, I also don't want to be ill for 24 hours again.
Every time I get a shot, they shoot it right in my nerve.
Oh,
so
no.
It hurts for like 2 weeks. Every single time. One nurse I done that.
I also have an intense fear of needles, so it's like really an event. Every time I go get a shot, I have to really hype myself up about it. See, and I'm terrified when they draw my blood because they messed mine up once and I like stopped bleeding in both arms. I had these giant bruises. Oh.
Oh, wow, that's gross.
Oh.
I was doing one.
Yeah, I asked them to do the pediatric needles now because I'm like, I'm terrified.
Yeah.
They're like, fine.
I did blood
Really
work
tiny
once.
veins.
It was even when I got my ears pierced. So I overhyped myself a lot. So like I did because I hate needles.
Yeah.
It's like a really tense. And I'm like
Oh,
afraid of
yep.
everything. And then there's like after it's over, there's like nothing that happens. So my brain's like, oh, it's over now. Passes. I just
So,
I build up all this stress and anxiety.
Yeah.
And then after it's over, my brain's like, oh, we're done now.
yeah.
And I'm just. There was one time though she like missed my vein like 4 times,
Ooh.
which is crazy because look at my veins.
See, I have
How do you
baby,
miss this?
I have little baby veins.
I was in this class over the summer for training for like medical,
Yeah.
and they had people like upper level medical that
Uh-huh.
were coming into our class trying to see who had the best veins, so they can practice like I have veins here and on your arms. And
Like, look at my veins. What do you mean? You miss
Yeah, I have
this?
nothing. I have nothing.
I have Asian veins. How do you miss this?
Is that a thing?
Yeah.
Okay.
You just see my dad's veins.
It's like they missed it like 3 times,
Oh,
and so
I hate
got
that.
all, like sick.
I hate
and I
that.
threw up, and I was like
Oh.
very bad. I was very upset.
Well, now that I'm super uncomfortable, let me finish teaching you.
Back to math.
Oh, icky. What's wrong? Is there a party going on? Do I need to bust it up?
No, it's okay. They left. But after I went into my stall that I was waiting forever for, it smelled a little fruity. If you know what I'm saying.
I do. Oh, those bathrooms are scary.
I can't walk into a bathroom anymore without smelling until they're and I'm like, why?
That makes me sad.
Like literature. Like literature classes. Why would you do it?
Yeah, no.
Yeah, that's fair.
All right. So I promise the next question is definitely going to be the hardest, but once we're done with that, we're essentially done with notes for today. And this is what happens if we get an improper fraction. Now, I will say that this will probably not happen to you on, definitely not on a test, most likely, unless it's a bonus level question. But this is really not something you have to be worried about all the time, but it is something we have to be worried about some of the time. So let's talk about it. Partial fractions, I guarantee, will not work correctly if you start the problem right now. And that is because we have a cubed on the top and a squared on the bottom. If you start to do partial fractions, it will appear to work though. And you'll be like, yeah, I did the question. I love partial fractions. I'm so happy. And then if we were doing like a mastery test, I'd come over, I'd be like, no. And you'd be like, what? It was a really long-winded explanation, but we need to find a way to essentially make this really like a mixed number instead of an improper fraction. So what's a fraction bar mean? What operation? What's the your least favorite way of dividing? Long division. Let's do it. All right, we've done long division a couple of times. So let's see if we remember. This one's a little bit grosser than the one we did last time. You're probably going to want to write small. We won't need very much room for this question, so if you want to encroach on its space, that's fine. Actually, I'm going to move up a little bit here. All right, does anyone know what goes inside the long division thing? Really?
So like you flip the fraction, you'll find it.
Yeah, so this is not the most fun. Again, this is not going to happen vastly all of the time. Okay. What goes here? All right, how are we getting 2x? I agree with you. All right, 2x and the x squared makes 2x cubed. Let me point to. You want to know what times x squared will get you 2x?
I'm in algebra all over again.
Sorry.
This is actually like fifth grade.
All right. We also, it's going to be easier if I
Long
point.
division.
Yes. This is long. Oh, he was in the bathroom.
Oh.
All right, now we want to distinguish. So what is 2x times x?
Why can this call never be over?
2x squared. All right, what is 2x times negative 2? All right, I'm about to do something down. What is that? All right, just me and Lily over here. No, I need someone to talk to. All right, those should cancel. If they don't, you did it wrong. All right. What? That's just a fact. All right, 1x squared minus 2x squared. Negative, and I'm going to write negative 1x squared just to be a little extra, just to really, yeah. The minus 4x. So essentially taking this thing and distributing it into these three terms. So 2x all right. Negative 7x minus negative 4x. So negative 7x plus 4x minus 3x. Yep, who's coming to the party? 7. All right. What goes in the blue box?
Yeah, because it's negative 1x squared on the bottom, because that x overlaps, so it cancels out.
So what times x squared?
Negative
one x.
Negative x.
I thought we were going on the X. This is the second.
No. Good. Okay, I understand. We need to still focus on the x squared at the
Oh.
front end. So what times x squared will give us negative 1x squared?
Negative 1.
Negative 1. All right, cool. Because we're going to distribute this negative 1 into all three terms. So the leading term will still be from that x squared. All right, so negative 1x squared. Negative 1 times x is negative 1x. Negative 1 times negative 2 is plus 2. All right, we are going to subtract down negative 1x squared minus negative 1x squared. Those cancel. If they don't, you did it wrong. That's okay, we're going to be done after this. Negative 3x minus negative 1x. Negative 2x. 7 minus 2.
Let's go.
All right. Now I said we were going to be done after this step with the long division. Yeah, did I lie? Are we done? How do we know? Good. Jill, your algebra is on fire today. All right. If we look at this, there is nothing I can multiply by x squared to get 2x that is like a whole thing. We'd have to start using fractions. So this guy is our remainder. All right. So let's talk about how I would rewrite this integral. We had a pause in the integral. All right. What is going to come first in my integral? 2x minus 1. That's the stuff that got cleanly divided. So that will be chilling in the integral. The remainder, negative 2x plus 5, is still being divided by x squared plus x minus 2. Shoot. What? No. There's a lot happening right now. It is all happening on this. Should I switch sides? Is it me? What is that TikTok? Is it me? Am I in the drama? All right. A lot.
Blacked out.
What I would like to do, I'm just going to speak quietly.
Numbers.
What I'm about to do, I am going to factor the denominator. Because I think we're still on the partial fractions notes. I still have a fraction that I would like to be more than one fraction. I'm a factor. It was me. They got quiet. I'm sorry, everyone. All right, I think it's x plus 2 and x minus 1. Do you agree with me? All right, what I would like you guys to do, because I'm done doing a bunch of work. I'm going to let you guys do it, and I'm going to trust you. Not really, because I already did this. Hold on, I'll give you instructions. I want you to use partial fractions to find me those two numbers. You have 3 minutes. So I would, what do you mean by that? So I would do the partial fractions process we've done on this set of fractions. Yep, so you only need A and B because we're only dealing with two fractions. I would kind of just ignore the 2x minus 1 right now. All right, if you think you know what you're supposed to do that. If you don't, call me over.
So do we multiply the whole thing by this? Would it equal 1?
So for this, did we multiply by the bottom? Are we not exactly? I was trying to say, is the remainder problem right now? I got it. Yeah. Oh, and that's just evil action. Honestly, I don't know. We're not really wanting to know. We're trying to. So he's not a part of this party. I'm guessing it probably would do some weird things here. Although maybe not, because both of their convenient X values would probably be better. But actually,
But like, would you just write like this 2x minus 1 and then in parentheses, you put the equation?
Yeah, because you have both of them. It probably would write anything up, it would just make your.
It would just be longer. Yeah. But then you get everything done in one.
Oh, no, I got.
You should be getting two nice numbers again. If you need help, current partial fractions master, James. Yeah, we will eventually. Yeah, -3 is right for one of them. All right, check me if you can. All right, do you guys like my A and my B? -3, 1? We good? You still technically have a minute? We good? All right, Sushan's good. Some people are good. All right, I would like to finish up real quick. So looking at these, one thing I noticed, am I going to need inside that like yellow circle thing, am I going to need any U sub for either of those? No, I'm not going to. I do need to remember that the 2x and the -1 still are part of this integral and need to be integrated. What is the integral of 2x? X squared. How about the integral of -1 minus x? And then I'm just going to go with my natural logs, which you could combine. I'm just going to choose to keep them separate for now. That is definitely as hard as I would ever consider putting on a test. And honestly, is definitely harder than I would consider putting on a test. That long division is a lot of algebra skill. compared to the amount of calculus still going on in this problem.
Yeah, it took more time on the.
Yeah.
The actual calculus.
All right, the last thing I want you to start thinking about is some questions like this that look like they may be good for partial fractions are not actually going to be good for partial fractions. So we're going to start meeting kind of a hierarchy for which methods we're going to look for first. So let's look at a question down here. It's going to take us about 2 steps to do. Does this look like it might be good for partial fractions? Well, it's a fraction. The bottom looks kind of good, but then I look closer. How many things do we normally factor that have an x cubed at the front? Not a lot. I actually personally don't know how to factor that. I don't know if it does factor. So what method might I try other than that? Let's try u sub. What is u equal to? Let's try the bottom. So what's du then? All right, that looks kind of familiar. Okay, let's try to take out a 3 like Brandon's saying. 3x squared plus, ooh, that looks good. I could move this 3 over as a 1/3. Yeah, I was just doing it in 2 steps to be really obvious. And that's exactly the numerator. So I could call this, if I'm substituting, 1/3, and the du would go in for the x squared plus 1 dx. The stuff on the bottom is just u. And we've integrated this a million times. What happens if I just have 1 over u du? We've done it a million times today. Natural log, absolute value, and I'm just going to put the u back in. So I just want to throw it out there. U substitution is a method that will be on your Unit 6 test, even though technically we didn't learn it in Unit 6. This method is usually the one you want to check for first, because compared to some of the other things we're doing, U sub is a heck of a lot easier than some of the other things. All right, how do we feel about partial fractions today?
Actually good.
Actually good?
Yeah.
Good enough to maybe want.
Yeah. I'm down.
Well, it's your lucky day. We have a nice chat.
Should we check for use of on this too or not?
No, I guarantee these are both partial fractions, and the one that has like not just x squared is already factored for you. You're welcome.
Thank you.
All right, try this by the end of today. You have 4 questions. No, not my way. Passing out 4 of these. You have 2 questions, a little under 10 minutes. Try your best.
I'm passing out.
There's 2 questions. Sorry, I was passing out 4 papers.
No, it's not like.
Yeah, that would be a little aggressive. I needed like 6 questions to hold one. I know this question is remarkably short.
I got 3 today, was second time. So start off like.
Oh, everyone's gonna be so happy next time.
Yeah.
Oh.
There's only one line. Let's go private. But guess what? If you're really good at this,
I think that's
Brandon, are you okay?
this is one,
I don't know.
yeah, for you.
You're telling me.
You just.
Oh, believe me, I am.
I do it in my head.
It's like, is this wrong? To make it like forward. No, not at all.
Okay.
Whoa.
I would multiply the option maybe
You know, I think at least the first one.
I got it. It's still good.
I was looking exactly like that one.
Very, no, it's very creative.
I love how you asked the
I have no idea. I have no idea.
What, you don't?
I don't know.
Supposed to.
No.
No, she's not obligated to.
If I, where's my calculator? Hold on, I might be able to find it with my calculator.
Who created these? It says your name on them.
I didn't, yeah, but I probably created it like you. I'm also trying to not very smart.
Two is I see.
That's not a evil move this happening.
Well, it's also a lot easier to reverse engineer it, because I would like make the two fractions and then add them together. That's my calculator. No, it has a back. I think it's that far.
Have you seen batteries in the cycle?
Oh, 1 second.
If you put batteries in anything else, they die.
Yeah, TI has some really good stuff, because that's like 80s. I have no idea. I have no idea. I don't know, you could check with someone else who has letter C.
I have.
What'd you get for number one?
Oh, wait, like already cracked that.
Oh, God, it's too thorough.
I have
It's not very fun.
Do you have ugly and nice? Which I said.
Oh, this is gonna have pregnant.
Yes. Yep, so since this one, we didn't have to be partial fractions because we do and the math. So when we substitute it, since we did, we go back and just integrate this, we did. Yeah. So kind of the moral of the story there is we don't have to do partial fractions. Yep. The top ended up being a third among you. So it was interesting.
All right, I'm going to talk at you a little bit. If you're not anywhere close to done, I'm going to give you some options. So next class, we're going to be doing probably my least favorite lesson in this unit, trig integrals. Yeah, it's not my favorite. So we're going to literally only do 4 problems, and it's going to be when we have a higher powers of trig. So we're going to be converting between sines and cosines, secants and tangents. It's not horrific, but it will take a little bit of time. We will probably have some extra time. It won't be like today where 6 problems took the whole time. It'll probably be like 4 problems takes half of class. So bring your problem set if we have extra time. If you're feeling great about this notes check, you want to take it home to finish it, that's great. If you are feeling like you want to pause and we can revisit at the beginning of next class and you just kind of want to see if you got anything right, feel free to drop it here before we leave. I'll go through like I did last time and kind of check off the ones that are right, but we'll start next time by finishing up this guy and working on our problem set for a little bit. Thank you guys for your hard work today and continuing our hard work as we move throughout this unit. Kind of schedule wise, we've got 2 more lessons. We'll start unit 7 and then we're looking at the test. Right now it's scheduled the kind of last week of the quarter, but it will go on 3rd quarter. So if you want to drop what you got, you drop it up here. If you want to keep it with you, keep it with you. I will see you guys on Friday. Yeah. What's that?
Is this supposed to be this gross?
I have no idea. Oh, I'd multiply by 2 on both sides.
By 2?
I don't know.
Because it's like
I have no idea.
this is the thing, right? So it's this and this, right? Is this the right idea? So then these become these points, right?
Wait, I would do -2/5.
Oh yeah, 2/5. Yeah.
Yeah.
But then can I
It might
multiply
be
by
nasty. Yeah, you could. You just have to
Do
distribute
you
it.
want
to
to
both
turn this
things.
one or take it with us?
Either one is fine.
Also, is this right?
I have no idea.
She hasn't checked. Thanks.
So then
I just don't have all the answers.
if this
memorized.
is 2/5, if this is 2/5, right? And